For the lesson 1.4 Ready, Set, Go, we are talking about rate of change. So again, as mentioned in class, we're talking about slope, rate of change, the difference of what's happening for our output for every input. So a lot of different ways that we can talk about this. I want to look at number 2. So if you look at number 2, there are a few different ways that we can approach this. The first of which is what we've been talking about, the common first difference. So the common first difference for each of these is -2. Also, if you look at the graph and I start at that first point, so I start here at that 1,13, I go down to over 1, I notice that there's a pattern that's forming. Down to over 1, down to over 1. So I can say that the rate of change is -2 over 1. For number 4, doing something very similar. Noticing here that either the common first difference is +4 each step of the way, or on the graph, noticing that I'm going up 4 over 1, up 4 over 1, up 4 over 1. So you could say that the rate of change is a 4 over 1, or that the first common difference is +4. Number 6 starts to get a little bit challenging. Notice that we have a geometric sequence that we're trying to build. So we're looking at that exponential. We're trying to figure out what we can do to write the recursive and explicit equations for each of the patterns that is happening. And because it's geometric, that really helps identify what's happening. But we should see that to get from 3 to 6, 6 to 12, 12 to 24, I can multiply the previous step by 2. And if I wanted to plot this out, I can try to say 3, 6, 9, 12, 15, 18, 21, 24. I know it gets a little bit sloppy, but the 1, 2, 3, and 4 down at the bottom. So I know that I would end up with 1,3, 2,6, then it starts to get much bigger, 3,12, and 4,24. So it's going to follow an exponential curve. I'm going to erase the input values down here just to give me a little bit more room to talk about the recursive equation. So for the recursive, remember we want to try to identify our first step. So our first value in this case is the input is 1, the output is 3. To find our next term, we will take our previous term and multiply it by 2. That's all this is doing. For the explicit, we're looking for any moment in time. I want to be able to figure out the number of days, the number of cells. So in order to do that, we first identify our first term, which is 3, and then we multiply it by our common ratio, which is 2. Okay, we're multiplying it here by 2, to the n minus 1 power. And you are done. For number 8, we've got a situation where a chain letter is going out. And it might be a little bit easier to create a table and then create a graph. So I would say that we have a day number here, and we have friends as our output. So our x is days, our f of x, our output is friends. So on day number 1, Tanya sends it to 4 friends. Each day, that friend is then supposed to send it to 4 new friends. So on day 2, there are 16. Day 3, there are 64. Day 4, there are 256, and so on. Each day, we're multiplying by 4. So to mark that here, I know that it has to get pretty big. So what we can do is we can say that this is 100, 200, and 300 up here. Day 1, it's 4, so it's all the way down near at the bottom. Day 2, it's 16, also really close to the bottom. Day 3, 64. Day 4, 256. So it looks something like that. Just as importantly, we also need to be able to identify the recursive and explicit equations. So on day 1, it was sent to 4 people. Every next day, we took the people from the day before and multiplied it by 4. For the explicit, we have f of n or f of x. I'll keep it consistent there. F of x with the table that you have. Our first value was 4. And then every day, so that common ratio is 4, x minus 1. For number 10, we're talking about arithmetic sequences. So we're talking about adding or subtracting to get to our next value. So looking at number 10, I'm going 2, then 4, then 6, then 8. I know that each time I'm adding 2 in the step. So step 1, step 2, step 3, step 4, step 5. And let's go 4, 5, 6, 7, 8, 9, 10. So step 1 had 2. Step 2 had 4. Step 3 had 6. Step 4 had 8. Step 5 had 10, and so on. So you should be able to create a straight line, and that's not perfect. There we go. Pretty good. So for the recursive equation, again, we want to say where we started. Our step 1 was 2. Then every step after that, we took the step right before and added 2. Okay. For the explicit equation, again, if we're following the guide that was given to you earlier, you would take f of n equals, if I want to find any number, I'm going to take the starting, the common difference, times x minus 1. If we wanted to simplify that, we would take that 2 and distribute it in. So 2 plus 2x minus 2. And in this case, it would simplify out to simply 2x. The plus 2 and the minus 2 zero out each other. For number 12, Claire starts with $300 in her account. This is like something that was done much earlier in the module. So starts with $300 in her account and then takes out $25 each month. So at the end of 1 month, 2 months, 3 months, 4 months, 5 months, I want to be able to plot out what that looks like. And if you wanted to create a table, you certainly can. But let's say that this is 200, this is 100, and here we go. So at 1 month, taking out $25 would get me 275, so somewhere around here. At 2 months, there's another 25, so about 250, somewhere right around here. 3 months, another 25, 4 months, and this should all look like a straight line. Let me clean that up. So 1 month, 275, 2 months, 250, 3 months, 225, 4 months, 200. And so what you'll see as you build through this, let's clean that up. There, we have a nice bold line going down through there. And the big thing here is just understanding that we are slowly decreasing the amount in the account every month. So the recursive, we would set this up as f of 1. So our first, actually let's say that this one is our f of 0. We start out with $300. Okay, after 0 months, you have $300. And after every next month, you take the month right before it and subtract $25 from it. The explicit, it's a little bit tricky because what we need to do is we need to figure out the f of 1. So after 1 month, we know that Claire is going to have $275 in her account minus $25 every month. Okay, plugging the rest into the formula into that explicit equation. If you wanted to, we can simplify this out by distributing the negative 25. So 275 minus 25x plus 25. So every month we know that we have a formula that we can use that says negative 25x plus $300. After 0 months, 300. After 1 month, 275. 2 months, 250, and so on. For number 14, back to the dots. Being able to plot the dots on days 1, 2, and 3, and so on. So plotting these out, day 1, 2, 3, 4. Day 1, we have 6 dots. And what's happening here is that as you go through, we've got 6, then 12, then 18. So I know that we're going to be going up by 6s. So you could, if you wanted to, go up by 6s here. And plot them out. Day 1, day 2, day 3, day 4 should be a straight line. Okay. Plotting it out, day 1, 2, 3. That's a 3 and that's a 4. Okay, so for our recursive, we know that on day 1 there were 6 dots. And on day n, we're going to take the day right before it and add 6. Remember, it's an arithmetic sequence, so we're going to either be adding or subtracting. For the explicit equation, for any number of days, we can find the number of dots by taking what we started with. So our day 1 was 6. And then our common difference was also 6 times x minus 1. Distributing this in to simplify, we can take this to get 6 plus 6x minus 6. This positive 6 and this negative 6 will zero out. So you should end up with f of n equals 6x. Hopefully this helps. Reach out with any questions you might have.